So in the previous lecture we have discussed the basic properties of discrete time Fourier transform, and moving ahead to this topic, do one some questions related to this topic. Find find the Fourier transform, discrete time Fourier transform find the discrete time Fourier transform of f of n is equal to u of n minus u of n minus 9. This is discrete time signal. If you plot in discrete time domain, you will see it will look like this. F of n starting from 0, 1, 2, 3 up to 9 sample of unit step function. Which have magnitude 1. This is the time domain representation of this function. To do this, you have to follow simple approach, that f of omega is equal to summation from n is equal to 0 to n, means summation limit will change because the signal is defined only in the range of 0 to n. For this value of n is defined, rest everything will be 0. That's why I am taking here summation range is from 0 to n. F of n e to the power minus j omega n, and from n is equal to 0, f of n have value 1 e to the power minus j omega n. This is a summation of finite sequence, summation of GP series, isn't it? GP series with a finite length. Do the simplification and write your result. Like that, you can find any of this sequence. All of this type of question will be very simple. Now, another type of question you may ask, that discrete time Fourier transform of f of n if f of n is defined as a, b, c, d. This is a general 4 sample sequence, and Fourier transform of this value, this sequence is f of omega. If Fourier transform of this sequence is f of omega, is discrete time Fourier transform of f of n. Then find the inverse Fourier transform, inverse DTFT, inverse discrete time Fourier transform of f of omega minus pi. f of n is discrete time signal and f of omega is the Fourier transform of f of n. You have to find the inverse Fourier transform of f of omega minus 1. Here in this question you can see that this is a question related to the frequency shifting in frequency domain. What is the effect of shift in frequency? Suppose f of n have Fourier transform is f of omega. Then if you shift in frequency, it will affect in time domain. And what is the effect? It will be multiplied with a phasor. If you recall the property e to the power j omega pi, it will become f of omega minus pi. Isn't it? This type of property, time frequency shifting property, we have discussed. And see here, let's say where n should be there, n pi to the power j n pi, and it will shift in frequency. Similar type of property what we have discussed in time shifting also. So there are two properties related to the time shifting and frequency shifting. If f of n have Fourier transform f of omega, so the shift in time n minus n naught will affect in frequency domain, and it will be the change in phasor minus j omega, this type of property. This is time shifting property. This is time shifting. Here this is frequency shifting. By here, see in this question there is use of frequency shifting property. So you will apply. What will be the inverse Fourier transform of f of omega minus pi? Inverse Fourier transform I dt ft of this sequence will be f of n e to the power j pi n, and accordingly you have f of n is given in this question. If an arrow below to any sample is not given, it means by default it is assumed that first sample should be at origin. So put the value of f of n, that is a, b, c, d, but keep remember that this is at n is equal to 0, this value is at n is equal to 1, this value is at n equal to 2, and this value is at n is equal to 3. All of these sample will multiplied with this value e to the power j pi n, and here the value of n is phasor. This value of n will be according to this samples. You should put, suppose this is g of n, then what will be the g of n? It will be a e to the power j pi 0. This will be the first sample, and second sample will be b e to the power j pi into 1. Third sample will be c e to the power j pi 2, and fourth sample will be d e to the power j pi 3. And this value e to the power j pi 0, this will be 1, it will remain as it is. This value e to the power j pi will be minus 1. So it will become minus 3. Again, e to the power j by 2, the value is c, this phasor value is 1, and e to the power j by 3, this value is minus 1. So it will become minus d. And you can observe here that all the sample are as it is, but there is a change in the uh, even numbered sample. This is sorry, odd numbered sample. Odd numbered sample will invert their sign, and all the even numbered sample that will remain as it is. When you now keep as a note that when discrete time Fourier transform is shifted by is shifted by half of the time period. This is generalized term, half of the time period or pi. Then what will be the effect? Then sine of the odd numbered samples will be inverted and remain rest will be is for all odd value, that is for all odd value of n, sample will be inverted. Sample value will be inverted. So this is one observation that you can see this shifting. Now again, see another question. Discrete time Fourier transform of f of n dt ft of f of n is equal to f of omega, and it is defined as 4 minus 2 e to the power minus j 2 omega. Then find the dt ft of n into f of n minus 2. Here time shifting as well as multiplication in time. Those two property apply here and try to find the result. So what is the effect of multiplication? It will be differentiated frequency domain. And what is the effect of time shifting? Time shifting affects the frequency domain, that is multiplied with the another phasor. Frequency spectrum is changed. When there is time shifting in time domain, there will be effect in frequency domain. What is the effect? Effect will be phasor is multiplied with the magnitude scale. See, if here f of n is defined their Fourier transform that f of omega, and it is equal to 4 minus 2 e to the power minus j to omega. And if you shift in time domain by type 2 unit, it will be f of omega e to the power j omega into 2 also minus. So it will be e to the power minus j 2 omega multiplied with your actual f of omega, that is 4 minus 2 e to the power minus j. By solving this, you will get 4 e to the power minus j 2 omega minus 2 e to the power minus j 4 omega. Now it is multiplied by n. So what is the effect? It will be differentiated e to the power minus j 2 by this whole term will be differentiated with respect to omega. Now this whole term is differentiate with respect to omega. 4 e to the power minus 2 omega minus 2 e to the power minus j 4. Try to solve and see the result. This type of use of the properties of Fourier transform you should know. Another question, see, find the inverse Fourier transform, inverse discrete Fourier transform of f of omega. Also find the f of 0. Means you have to first find f of n, after that f of 0. These two no. And f of omega given f of omega is like this. This is from minus infinity to plus infinity. Here minus pi, here pi, here 2 pi, here minus 2 pi, like this. Now you have to find, and this value is minus omega naught, this value is plus omega. We have already discussed that f of n means inverse Fourier transform of discrete time Fourier spectrum or discrete time Fourier signal is integrated in one time period. See, in this case, this f of omega is given in the periodic nature, having period of from minus pi. See, actually this signal repeats from minus pi to pi after that, like that. So your integration will be limit from minus pi to pi, or if signal is defined from origin beyond that, from origin to right side is for positive frequency, so you can take the integration limit from 0 to 2 pi. But here integration limit will be minus pi to pi. and e to the power j pi n d of omega. This magnitude is 1. Now simplifying this, you will see that from minus omega naught to plus omega naught, f of omega is 1 and e to the power j pi n d of omega. Now here directly if you put the value of n is equal to 0, put n is equal to 0, you can find f of 0. And what will be that? That will be integration from minus 5 or from minus omega naught. It should be from minus omega naught to plus omega naught 1, and this value will be, when you put n is equal to 0, this phasor will become 1 and d omega, and that will be equal to 2 omega naught divided by 2 pi, that is omega naught by pi. If you find this value at origin of 0, this is very simple. This only integral, you have to integrate in one time period. But another spectrum for all the value of n, you should take the integration and you have to simplify the signal. Now simplifying this f of n, you simplify this integration from omega naught to plus omega naught a to the power j omega n d of omega, it will be e to the power j omega n divided by j omega, sorry, j n and limit of this integration is from minus omega naught to plus omega. And finally, if you simplify this value, you will get sine omega naught n divided by pi. Do the simplification and verify whether this result is correct or not.
आ रहा है सर।
आ रहा है, ठीक है।
यस सर ठीक है सर।
So these type of question you can face anywhere in this topic. So one another question. An LTI system is defined by y of n is equal to 3 by 4 y of n minus 1 plus 1 by 8 y n minus 2 is equal to, sorry, here this is not equal to, it is minus yn minus 3 by 4 yn minus 1 plus 1 by 8 yn minus 2 is equal to xn, where yn is output and xn is input of the system. Then find the frequency response h of omega of the system. one question. Another question. Also find the impulse response. Impulse response h of n of the system. This is very simple question. There are several methods you can by this question can be solved. One of the simple approach, take the Laplace transform and finally take the ratio h of s you will get in term of y of s divided by x of s. This is also frequency response, but this is by using Laplace transform. Another method, if you take z transform and you will take the ratio of these two, x of z divided by this but this is using z transform. Another approach, if you take continuous, this is because this is discrete time signal, so Laplace transform is not applicable here. You can apply z transform, and in that z transform, if you put z is equal to e to the power j omega, you will get h of e to the power j omega, and this is h of omega that you have been asked in this question. Or directly, if you apply discrete time Fourier transform and finally take the ratio y of omega divided by x of omega. This is possible. There are two methods. For the simple, those who have studied the z transfer, they can all apply also, but those who are not knowing the z transform, they can directly use this. To the question, what is this? Question, y of n is suppose would be, let's say, then what will be the Fourier transform of yn minus 1? It will become y of omega e to the power minus j omega n naught 1, and another yn minus 2, what will be this? This will be y of omega e to the power minus j omega 2. In similar way, we can write Fourier transform of x of n is x of omega. Now, all these assumptions can be put in the given expression, and finally you will get y of omega minus y of omega e to the power j omega, but there is coefficient 3/4 minus 1/8 y of omega e to the power minus j omega 2, and this will be equal to x of omega. Take the common y of omega from this left hand side expression. You will get y of omega is equal into 1 minus 3/4 e to the power minus j omega minus 1/8 to the minus 2 j omega. This is equal to x of, and finally y of omega divided by x of omega is equal to 1 divided by 1 minus 3/4 e to the power minus j omega minus 1/8 e to the power minus j 2, and This is equal to your impulse sorry, frequency response. H of omega will be y of omega divided by x of omega. So it is 1 minus 1 by 8 it will become minus 2. This is your required result. This is one part. And another part, take inverse Fourier transform. You will get H of to find the inverse Fourier transform, you have to follow some modification. You have to do some modification in this expression. H of omega can be expressed, represent this expression in the form of factorization of two terms, factor of two terms. This term, by factorizing, you can express. This factorization can be done by your elementary knowledge of school. It will be 1 minus half e to the power minus j omega into 1 minus 1 by 4 e to the power minus j omega. If this factorization is correct, then do the partial fraction. A divided by 1 minus half e to the power minus j omega plus b divided by 1 minus half e to the power minus j omega. Find the value of a and b. A will be 2 and b will be minus 1. And so h of omega will become 1 by 1 minus half e to the power minus j omega, and another here not 1, it will be 2. It will be 2 by this, and this 1 minus 1 by 4 e to the power minus j omega. Now if you recall the result, that there was a term that having Fourier transform 1 minus 1 by 1 minus a e to the power j omega. What was that? That was a kind of function that we have done in the earlier result. So sometime you have to keep in mind some standard results, that a to the power n u n, the z transform of this is 1 by 1 minus a z inverse. DTFT of this, so 1 by 1 minus a e to the power minus j omega. If you remember this result, then it will be helpful for you. What is this? This is where the value of a is half. So 2 is the coefficient and half is the value of a, and that will be here u. Another, here the value of a is 1 by 4, and so it is 1 by 4 to the power n. This is your h, and this is inverse Fourier transform of h. So very simple question. Now one part more can be added in this question. Determine Okay, let's do from beginning so that you can do practice also. If an LTI system is related as y of n minus half yn minus 1 is equal to x of n plus half x and minus 1. This equation describes the relation between input xn and output yn of any LTI system. Then question is find h of omega, find h of n, and third question is find the response of system when input xn is equal to cos pi by 2 into n. Now first two question is quite simple. You can repeat from the previous concept that we have discussed in the just before in this question. And if you find third question can be solved directly. If you find h of omega, if you find this value, and then what to do? You have to find the given input Fourier transform f of omega. We have to solve this, and finally the output will be y of omega is equal to h of omega into x of omega, and then take inverse Fourier transform of y of omega, which will be equal to y of n, and this is the response of system for given input. And I think all the concepts related to this question we have discussed. You can solve. This is for your homework. Any doubt?
हेलो
Yes.
सर एच ऑफ ओमेगा आया है 1 प्लस 1/2 e टू द पावर माइनस जे ओमेगा अपॉन 1 माइनस 1/2 e टू द पावर माइनस जे ओमेगा। तो इसके आगे इसे कैसे सॉल्व करें?
क्या आया है एच ऑफ ओमेगा?
एच ऑफ ओमेगा आया सर 1 प्लस 1/2
half e to the power j omega divided by
माइनस
1
का
minus
माइनस
half e to the power
माइनस जे ओमेगा। अब सर ऊपर और नीचे मल्टीप्लाई कर दिया मैंने 1 प्लस 1/2 e टू द पावर माइनस जे ओमेगा।
इसको थोड़ा सिंप्लीफाई कर लो।
यस सर।
x ऑफ n क्या आया फिर? h ऑफ n तो निकल जाएगा ना इससे, इसका इन्वर्स dt ft, तो h ऑफ निकाल लोगे, h ऑफ n वो तुम्हारा हो जाएगा 1/2 to the power n u of n plus half into half to the power n minus 1 u of n minus 1. So this is second question. This is first question answer of this first question. This is answer of the second question. Directly come the answer of second question. Third question will be response. Third question is response of the system. Response of the system can be found by h of omega into x of omega. Here h of omega is 1 plus half e to the power minus j omega divided by 1 minus half e to the power minus j omega, and x of omega is what? X of omega is equal to pi delta omega minus pi by 2 plus delta omega plus pi by 2. Now this x of omega is multiplied with this. Pi delta omega minus pi by 2 plus delta omega plus pi by 2. By simplifying, 1 plus half e to the power minus j omega divided by 1 minus half e to the power minus j omega into delta omega minus pi by 2. Another term, 1 plus half e to the power minus j pi divided by 1 minus half e to the power minus j pi, and it is multiplied with delta omega plus pi by 2. These two terms. Now if you wish to simplify, go further. Now try to simplify this. Should I proceed? Are you doing? Okay. Suppose this is one function f of omega, another function this is multiplied with delta function. Now recall one property of sampling property of delta function, that f of n delta n. What will be this? This will be f of 0 into delta n. Or one another property was that for the shifted delta n minus n naught, this will be f n naught delta n minus n. If you recall this property, here you can use this. What will be? this function, put here omega is equal to pi by 2. It will become 1 plus half e to the power minus j pi by 2 and 1 minus half e to the power minus j pi by 2 delta omega minus pi by 2. And another term will be pi 1 plus half e to the power minus j, sorry, here it will become minus and minus, it will become plus. Plus pi by 2. 1 minus half e to the power j pi by 2 into delta omega plus. Now express all these terms in your known function so that it will be helpful to simplify. e to the power minus j pi by 2 ये क्या हो जाएगा, e to the power minus j pi by 2, e to the power minus j pi by 2, it will be equal to cos minus pi by 2 plus, sorry, minus j sin pi by 2. This is 0. So this will be minus j. And what is the value of e to the power j pi by 2? It will become cos pi by 2 plus j sin pi by 2. And it will be j. Now wherever e to the power j pi by 2 or minus j pi by 2 is there, put the value j or minus j. So it will become e to the power 1 plus first term will be pi 1 plus, not plus, it will be minus j 1 minus half j, and here 1 plus half j delta omega minus pi by plus another term pi 1 plus j half and 1 minus delta omega plus pi by. Now try to simplify further. Now see these two terms, this is one term, this term, and here in this term, not containing the value omega. This is not a function of omega, not function of any variable. So it is a constant. This is also, this is constant. Here also this is constant, but it is complex. So it will have magnitude as well as phase. So try to represent these two terms in the form of magnitude and phase. What will be the magnitude of this first term? 1 plus 1 minus half j divided by 1 plus half j. What is the magnitude? Magnitude will be 1 means under root 1 square plus half square. This is for numerator. For the denominator, this is also 1 square plus half square. It will be 1. And what will be the phase? This is magnitude. And what will be the angle? That is tan inverse this angle of the numerator, that is minus half minus tan inverse half. It will become minus 2 tan inverse half. For the same here also, it will become here magnitude as well as phase. Magnitude will become 1 and phase will be here. Phase will be tan inverse half. This is the phase of this one. So try to express now in the form of phase and magnitude. Already here 1. So what will be the change now? Now it will become 1 pi. Magnitude is 1. Phase is this value. So express in the form of phasor. So write delta omega minus pi by 2. This value is also constant. Phasor is represented as e to the power minus j phi. Suppose this is phi 1, this is phi 2. So this is phi 1 plus pi delta omega minus plus pi by 2 e to the power j phi 2. Now it is quite simple. Further, if you express, you can see in this equation what is the effect and what is the change. Here delta function multiplied with the phasor, another delta function multiplied with the phasor, but this delta function is a part of some discrete time domain signal, है ना? Discrete time domain signal है वो इसका Fourier transform है, and Fourier transform is multiplied with any phasor. What will be the effect in the time domain? Because if some phasor is multiplied in the time frequency domain, what will be the effect in time domain? In time domain there will be time shifting. There will be time shifting. So it will be, again if you simplify further or directly represent this term in the discrete time domain. Inverse Fourier transform of this delta function pi e to the power j phi 1 and this delta function inverse Fourier transform of this part. What will be that? डेल्टा फंक्शन फूरियर ट्रांसफॉर्म क्या होगा? e to the power something ना, e to the power j pi by 2 and also there should, but if subtracting all the value from phi 1 and phi 2 and taking this inverse Fourier transform, it will be simplified as this. And finally rearranging all the term and expressing this term in sinusoidal form, you will get a cos kind of function omega sine pi by 2 n minus 2 tan inverse half. Actually earlier, see, try to simplify, this is at your home, but keep this result. Observe, earlier x of n was cos pi by 2 n, and finally you will see that y of n is equal to cos pi by 2 n minus 2 tan inverse half, means one phase angle is changing and rest in this cos pi by 2 and cos pi by 2 everything is same. It means only in the change of angle occurring by this Laplace LTI system h of omega. What does change? Only change happen in the change in frequency for this input. So there are certain set of inputs called eigen function. Eigen functions are those functions for which output remain as it is. If eigen function are those functions which passing through the LTI system remain as it is. So this is one concept of this related to the eigen function also. But there is certain change. Remain as it is means it does not change anything. It means it changes, but characteristic does not change. Magnitude may change. Magnitude change. Phase change, but behavior does not change. It means it is sinusoidal, so it will remain again sinusoidal. Magnitude will change, phase will change. Here magnitude will not change because magnitude is 1. Here also the total magnitude of the given function means h of omega. Magnitude of h of omega, you will see here the magnitude of this h of omega is not changing. Magnitude of h of omega does not change. That's why output of the, now keep one result in mind so that you can not get confused, or you can verify your result by your own whether it is correct or not. If sinusoidal, sine, cos, or phasor, etc. This type of input given to any h of omega, output will be sine, cos, and e to the power omega. But there is a change, there may change magnitude and phase may change. And how this magnitude and phase will change? According to the magnitude of h of omega. This is magnitude and e to the power angle h of omega. This is the phase. This magnitude will reflect here and this phase will reflect. This is impulse response of, or the frequency response of LTI system, and this is called eigen function. So this is your for your note. Keep this is your. So till now, anyone have any kind of doubt? If not, we should close here and we will again meet in the next class. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.